Cool guys, so the next question that we have is maximum subarray. The question says, given an array nums, find the subarray with the largest sum and return its sum. So basically you will be given an array. What you need to do, you need to find the maximum sum of subarray and you need to return that sum, right? So let me just quickly copy this array and let me analyze this question. Yes, so what is said over here, this is the array that is given to us and we need to find the subarray that is having the maximum sum. So what is subarray, guys? Now subarray is not something that I pick 4 from here, then 2 from here, then 1 from here. No, you cannot do something like that. You have to pick the elements in a contiguous fashion. So you cannot leave out elements. You have to choose a starting point and you have to, for example, choose an end point, and you need to take all the elements within that start point and end point, and that particular subarray, whichever you choose, should have the maximum sum. You need to return that sum, right? So that is the question, maximum sum subarray. So obviously the brute force approach is, if you try to find out all the subarrays and you add all the subarrays and you keep track of the maximum, you can do it in that way. How can you do it? Obviously the first the subarray will be -2 alone, then -2 and 1, then -2 1 and -3 together, then -2 1 -3 and 4. Similarly all the elements will take place. There are 1 2 3 6 and 9 elements over here. So this is a subarray of size 1, this is a subarray of size 2, size 3. Similarly we'll make the subarray of size 9, which will include all the elements. After that you will start from this 1. You have started from this -2 was there. Now you start from this 1. Singular 1 is a subset, a subarray. Then 1 and -3 is also a subarray. Then 1 -3 4, this is also a subarray. You are getting the point to where I'm getting, right? Next you will start from -3, then -3 4, everything like this, right? So you can make all the combinations and make this, take the sum of all this and maintain a max variable which will get updated as soon as the maximum value appears, the maximum subarray appears. Obviously this is a nested loop approach, very simple. Your I will run from 0 to n minus 1, and inside that your j will run from I plus 1 to n minus 1. That's the only criteria, guys. This is what you should do from I only, maybe not I plus 1, because you need to make subarrays of size 1 as well, right? So initially it should run from I to I only, then from I to I plus 1, then from I to I plus 2 until n minus 1. So these two nested loops will do the trick. Inside the j loop we will calculate the sum, we will increment the values with the newly coming integers, and after that you will also set the sum to 0 in outside the j loop. Inside the I loop also will keep the track of the max in the inside the I loop and outside the j loop. These are simple nested loop approaches. I hope you will be able to do it on your own, and obviously this will take a lot of time complexity. It is of complexity n square, because basically there is a this nested loops are running. So this is obviously not the optimized approach, guys. This is the order of n square approach. We should be trying to do it in order of n. Now in order to do it in order of n, we need to look at certain things. Like, let me just quickly copy this entire thing again. If I take this, guys, now tell me one thing. What I need to do is, if I need to have a subarray with maximum sum, why am I including the negative elements? This is one of the important questions. For example, suppose there is a 1, then there is a 2, suppose then there is a -2. So what I am saying is, suppose I am iterating from the first and I am having two variables, one sum to compute the continuous sum, and there is a max variable to keep track of the max that we have, maximum sum subarray that we have encountered till now. First we come over here 1, so sum was initially 0, it became 1, okay, and maximum was, for example, -infinity at the start. Obviously 1 is greater, so it became 1. After that we take 2, so 2 also will be added to sum and it will become 3, and obviously max will also become 3. After that there is a -2, sum will become, obviously sum will will be decreased. Obviously max will not be decreased because 3 is not less than 1. That's why 1 will stay here only. But the point is, why should we include this minus 2 when it is going to decrease my sum? The simple answer is, guys, because maybe after this there is a very big number, and together if we take this, it will become a like it will be the potential result. And if we just stop over here, then we could not just take the maximum subarray. So at all positions we should not ignore this minus 2, or any negative numbers we should not ignore it, because after there might be a possibility that after this minus 2 there is minus 100, which will further decrease it, and it will never be increased, for example. Then also my max is already intact with 3. 3 was the maximum subarray. If no other positive numbers we get, 3 is the maximum subarray. That max is already stored in max. Either we will be getting a very big value after, either we will be getting a value greater than 3 if we include all the elements, otherwise we won't get. In both the cases, guys, my max is not having any problem. We should continue when a negative number comes. But there is only a particular scenario where we should not proceed, where we should reset our sum to 0. That was figured out by a scientist named as Kadane, and that is why this maximum sum subarray, this is also known as Kadane's algorithm, because he devised this thing that whenever you get a negative number, don't try to overlook it. At many cases it will be helpful, but there are certain conditions, guys. In certain cases we should ignore this. What is that condition? That condition is, if the running sum at any point, if this running sum over here at any point has become negative, then we should reset it to 0. Why? Because at any point, if it is, suppose we are starting with minus 2, why should we start? We should ignore all the subarrays, and we should always start from this one only. We should always ignore this minus 2, because if we take this every time, this will be contributing to decrease my sum. So always I will try to ignore this particular thing, right? That is the point, guys. That is the point. So if we come across a negative number which will decrement our sum, then we take it, no problem, with the hope that maybe we will get a greater max if we continue taking that negative number. But if after taking a number my resultant sum becomes negative, if it goes to negative, then we can reset it, because earlier part, if there was a max in the earlier part, we have already taken care of it. But if there was no max in the earlier part, this earlier part will not contribute anything positive to the rest of the part. So I will consider the rest of the part individually and reset my sum to 0. I hope you are understanding. That is the intuition. Pause the video, think over it what I am saying. Meanwhile, I'll just do a dry run of what I am trying to say. Not dry run, but a programmatic approach of how the things should work. Minus 2, 1, minus 3, 4, minus 1, 2, 1, minus 5 and 4. So what I am saying is, I will maintain two variables, sum and max, right? Initially my max was minus infinity and my sum was 0. After that I start iterating through this array. First I come across minus 2, so sum becomes minus 2. Obviously minus 2 is greater than minus infinity, so this will also be changed to minus 2. And as I have said, this is Kadane's algorithm, guys. Kadane algorithm, what it says, as soon as the running sum becomes negative, reset it to 0, because this is not useful. So I have reset it to 0. Suppose maybe there is a possibility after this minus 2 there are minus 100, minus 120 and minus 160. In that case minus 2 will only be the highest maximum possible subarray. And you can see in my max already minus 2 is stored. That is already taken care of. But we should not continue this minus 2 ahead. That's the point. So what I did, I forget about this particular array. What I was saying is, I was over here, I took minus 2, the resultant sum became minus 2, then I reset it to 0. Then I come forward, there is a 1, I increase my sum. Obviously 1 is greater than minus 2, so I should also manipulate my max. After that there is a minus 3. So minus 3 will make this thing minus 2. As soon as I make this minus 2, I'll just compare minus 2 and 1. Obviously 1 is greater, so I will not put minus 2 over here. But I will not keep it minus 2, I'll make it 0. Why? Because I'll go ahead with a fresh start. If I include this particular thing, or if I include this, or if I include this, any three of the cases, the resultant will also always be decreased because of these effects, As these effects are giving a negative effect, I should start fresh. There is no point continuing with a negative. From 4 I can have a -1. After the 4 I can have a -1. After that I can expect a 2. So the whole thing will be greater. So I should take this -1. But if this after taking this -1, if the resultant thing is become negative, that is where we should again reset the sum variable to 0. That is the whole point of this cadence algorithm. So basically 4 is coming over here, so I'll add 4 to 0. So 4 will become the new max as well. After that a -1 came. Okay, this will become 3. 4 it is 3 is less than 4, so we will not update it. After that there is a 2, so 3 plus 2 is 5. So we'll change the max. After that there is 6, we'll change the max. After that there is a 1. Okay, no problem, and we are not setting it to 0. After that there is 5. So in both the cases only there will be no change to max, and max will be 6. That is our result, as you have seen, right? The output was 6 only, right? So yeah, um, that's it guys. This was the thing. Only when you are getting the whole thing as negative, then only reset the sum to 0. And obviously in the while calculating this cumulative sum, you just keep track of the max. So in one complete iteration only we are able to you know uh, find out the maximum sum of the subarray that is present within our given array. And guys, we are not taking any other space complexity as well. These are two simple variables. Whether the size of the array is 10 or 10,000, we will only take two variables, sum and max. So that does not matter really. So basically the space is constant and the time is order of n, right? This is the time complexity and this is the space complexity. Let me quickly code it up. Pause over here. Those who have understood what to do, you can pause over here. Otherwise you can just follow the code. What I need to do is to find out the length of this array. Int n equals to nums dot length. After that we'll take two variables. Int sum should be equals to 0 and int max. I will initialize this with the minimum possible value of the integer range, which is, to do that in Java we do integer dot min value. After that we need to iterate through the array for int I equals to 0, I less than n, I plus plus, right? And what we do, we take sum, we increment the sum with the value of the present variable, present value. So nums of I, increment sum. After that what we do, we check if the sum that is formed by including this element, is it the greatest or not. If it is the greatest, we will be updating the max. If sum is greater than max, what we do, we change our max to sum. We assign sum to max. After that I also need to check if after adding this particular variable, if my entire sum is becoming negative. So if my sum is less than 0, if that is the case, I should reset the sum to 0. That's it guys. After the end of this for loop over here, we will get the maximum sum subarray in this max variable. So I can just return this max. I've shown you this, right? After iterating, we'll be getting 6 over here. Same thing only I've written in code, which is very simple over here. You can see very simple over here. 0 to n I am running. I'm calculating the cumulative sum. If sum is greater than max, we are reassigning max. Otherwise, if sum becomes negative, we are reassigning it to 0. Cool. Cool guys, it almost beats 100%. So this is the first solution that you have.